Hi chemistry students, this is the first lesson for Unit 8 where we look at chemical reactions and nomenclature, and this is an introduction to chemical reactions. So the point of this lesson is to get you to understand the nomenclature, that is the symbols that we use in chemical reactions, to write chemical reaction equations given the reaction description in words, and then to describe reactions in words given the chemical equation. Alright, let's get started.
Alright, so this is a basic chemical reaction drawn in the center here. You should very strongly write this down as well. But a chemical reaction is a defined process of a chemical change. As a process of a chemical change, if you remember from the beginning of the year, we had physical changes and chemical changes. Physical change is when the matter changed not chemically, so no electrons were rearranged. Whereas in chemical reactions, the electrons have to be rearranged in some manner to make it a chemical change or a chemical reaction. So what do we have below?
So we have a chemical equation. This is how on paper we represent a chemical process. So where A and B are the elements involved, or the chemical substances involved.
Generic elements or something.
Generic, yeah. Right. So this would be the chemical substances. And then we have X and Y would be numbers, and then we also have some symbols here. But in general, the things on the left we would refer to as reactants.
And of course, the things on the right would be the products, the things that are made. And there should be a Z or something in front of that AB as well.
Right. Okay, so there's a few other symbols here. We see this arrow symbol in the center that would replace, I guess, the equal sign.
Yeah, it means yields or makes.
Yield, so we can read this as yields. Produces.
Reacts to form. There's anything that means
makes.
To make. Any type of synonym will do.
But this implies, the reaction has a progress to it from, starting with these things to
ending with the products.
This thing over here. The numbers X, Y, and Z, those are known as coefficients.
And they're used to, of course, balance the molar amounts of things. You've practiced this, I think, in 7th and 8th grade already.
Right.
But,
so you've seen this before. So we're not going to dwell on this real long. We will oftentimes indicate the state of reactants and products with a solid, liquid, or gas.
There is one more state we should have there. That's the aqueous phase.
Okay.
Because things can be dissolved in other things. It's just other information that we can have.
And so that would be important to tell someone if you reacted them in an aqueous solution, you want to make sure you...
And then if there's any kind of extraneous information, like if you heat the process, usually certain things are written above arrows. They're not actually part of the reaction, but they are things that the reader should know. I don't think we're going to go at all into those. But they are something, if you were to see like a triangle above the arrow, or the word heat, or light, or something like that, that just means that's something they did to the reaction to cause it to occur, or to help it occur. It's not actually a product or a reactant. Those are usually catalysts, or other such kind of things they put above arrows. But again, I don't think we're going to cover that at all. So let's look at some examples.
And look at some real examples.
So this is a picture of page 7 from your packet.
For this year's packet, anyway, the 2014 packet, and what you can see is they sort of look like chemical equations, except that they've stuck words in instead of the actual chemical formulas for the reactants and products.
So those of you who are weak on naming, this is going to be a bit of a pain, but this is a skill we need.
Practice.
Yeah, it's great practice. I've been harping on it for the last 8 or more weeks that you have to be able to name to pass this semester. So here's another example of needing to name. So let's start. The first one, we can do the first couple together. It says sodium plus sulfur reacts to form sodium sulfide. So the first two are easy. It's just Na, and technically it's S8 for sulfur, but we'll stick with S for now. If you're wondering what he's putting in the parentheses, those are little S's, meaning they're solid. Not that we actually know this, but we're assuming it's solid. And it forms sodium sulfide. So sulfide has a -2 charge. Sodium has a +1 charge. So it's NaS. And that's all. And we're going to assume it's also solid, I'm assuming.
Right, we don't know that from the information given.
But these are normally solid substances.
Okay.
Okay, let's do one more together. Let's do the magnesium plus hydrochloric acid yields magnesium chloride and hydrogen. In this question, it's also good to know your diatomic elements because, well, we have hydrogen. So first off, magnesium is, of course, Mg.
That's a solid metal, so
Yes.
I'll put solid.
Hydrochloric acid is one of those acids that you should know on site. We gave you a list of those at the front of your packet. It says Jersey Shore Area High School Chemistry Required Site Formulas. We have hydrochloric acid, nitric, sulfuric, acetic, and phosphoric acids all there that you have to know on site.
So we know that HCl is hydrochloric acid, but actually it's not hydrochloric acid unless it's HCl in the aqueous phase.
And then it forms magnesium chloride, and magnesium is a +2.
So we need to know that that ionic formula is going to be MgCl2.
And then hydrogen is one of those diatomic elements. There are 8 of them, and 7 of them form a 7 on the right, with hydrogen, the straggler, on the far left. And hydrogen is normally gas. It can be liquid or solid, of course, but
I would assume that
normal
this reaction,
conditions,
when we've done it in a test tube, it bubbles out as a gas.
Yeah, so that's how we do these. We're going to have a lot more practice. As you can see, the rest of page 7 here we're going to do together in class or have you work on alone. But if you have issues naming, either get out that naming guide that Mr. Ferguson made for you or come in and get help from us, because if you cannot name, the year is going to get a lot more difficult.
Right.
All right, have a good night.
So to finish up the lesson for a post-video question, why don't you try the next 3? And I added an annotation here. This is page 19 in this year's packet. We changed it around from last year. So hit the pause button and try the next 3. You can write the answers on page 19, or you can write them on the back of your note sheet as post-video questions. And then there's one more slide after this where we're going to take one and do it the opposite direction. Okay, so for one more post-video practice question, let's take one the other way. So here it is written in chemical symbol form, and we have a reaction equation, and I want you to write a sentence that describes that reaction. So we have CH4 with the little G in parentheses after it, plus O2, again with the little G, an arrow, CO2, again with the G, plus H2O with an L in parentheses after it as our products. So write a sentence that describes that chemical reaction. Give that a try, and we'll practice these some more the next time in class.